Okay, let's discuss about 8255 Programmable Peripheral Interface PPI. This chip is PPI chip. Now, as the name suggests, it's a peripheral interface, right? So, it will be used for connecting your input output device. Now, that you can connect directly with microprocessor also, that is possible, right? Then, why you require 8255 chip? So, the first question is why this chip is needed. The thing is, when you are connected your input output device directly with 8086, it is unreliable. Now why it is unreliable? Because 8086 will never give you any confirmation that it is received, like it has received the bits that you have sent or it has not received, right? So kind of handshaking is not available, so you will not get any kind of confirmation from 8086. So that's why it is unreliable. Now why 8255 is needed? Because 8255 will work on the concept of handshaking. Now what is handshaking? When some device is giving you something, the device need to ask the permission, the chip will give you the response. When you give the data, it will again give you the response. So this is a example of handshaking. Now because your 8255 is doing handshaking, it will give you the confidence that the data that you are sending or receiving are proper and it is a reliable communication. That's why this 8255 chip is needed. So I hope now it is clear, right? Using normal data bus and address bus, you can do communication of input output devices with your 8086, but it is unreliable. To make your communication reliable, we need some chip like this which can do handshaking, and that's how you can get the reliability. So that's why this 8255 chip is needed. I hope this is clear. Now how it is reliable? Suppose my input output device has sent suppose 10 right here, and now it will ask 8086, can you able to get this 10 right now? Like, am I able to send you? If your 8086 is busy, this 10 will keep with 8255. What like it will do with this 10? It will discard it? No, it will wait till your microprocessor will get free. Once it get free, it will send this 10. So you can say that then in that case your 8255 can wait for a very long time, right? Possible? Yes, possible. But here our major concern is not with timing. So this will 8255 will never concern with timing, it is only concerned with reliability. So our main goal is to get reliable communication. Get it? Now this is the basic structure how your 8255 chip will get fit with your architecture. So here you are having microprocessor, in between to your microprocessor and your input output devices you are having this 8255 chip. Now 8255 chip here connected with data bus because you need to send data and receive data, right? It is connected with input output device using three ports. It is called port A, port B and port C. Get it? So this is the basic structure how your 8255 connects with 8086 and input output devices. All ports are of 8 bit and all ports are of bidirectional, right? I hope this is clear. Now this is the architecture of 8255. As we have already discussed, this is port A, this is port B, it is of 8 bit. So here it is PB0 to PB7, again it is of 8 bit, so it is PA0 to PA7. Now port C is divided into two parts, as you can see. Now upper 4 bit is given like connected in upper part, below 4 bit is connected with below part. Now why is it so? Because we have seen that you need to do handshaking. Now if you want to do handshaking, right, in that case you need to do communication and you require some pins. So when port A or port B is doing handshaking, right, at that time these lines are used for handshaking purpose from port C, and that's why they are connected. As you can see, they are connected, and that will make your upper part and lower part. So port C can work individually as 8 bit also, and in case when handshaking is required, it can get divided into 4 bit part, upper part and lower part, and it can serve port A and port B that you can see from here, right? So this full part make a group A and this full below part will make a group B. Done. Now always it is a programmable chip, right? So you can actually program it. Now how to program it? You can send a commands. There are two commands that you can send: IO command and BSR command, beat set reset command, right? So there are two commands that you can send to your 8255, right? And where is the control signal, like where you can send it? Here and here. So here you can send that two commands, right? Now concentrate. Here suppose I want to print something on my printer which is attached over here, right? Suppose this is the example. Now my microprocessor will send some data, right? 8-bit data. It will come over here. Now if I want to print on port A, I need to know the address of port A, right? So I need to know the address of port A, port C, port B, and I need to know the address of control, like this control part also. Why you need to know the address of control also? Because when initialization is occurred, you need to like set this IO command and BSR command. There are two registers that you can set. For that you need to know the address of this. So currently we'll assume that the address of this port is 80H, this is 82H, port B, port C is 84H, and these control registers are having address of 86H. Okay, now as you can see all the addresses are even, they are not in sequence. Why? Because if you go and check the designing of 8086, we are having the concept of odd bank and even bank. So here the address, all addresses are only even address, like it is, you can't go with sequence, you need to take one address for spare, right? So that is interfacing part. Right now we'll not discuss that thing, but what is main important stuff is you need to know the address of four things: port A, port B, port C, and control block. You need to know that, right? So you need to know four addresses in advance if you want to communicate with your 8255. So this is required. Now as you can see, data bus is clear to send the data or to receive the data. These are the signals that you need to give to your 8255. Which are the signals? Two address bus. Why two? Because using two address bus you can address four different addresses, and we need to give four addresses. That's why it is two bus, A0 and A1. You need to give read signal, you can write also. So based on the input device and output device you can do this stuff. This is the reset pin and chip select pin. So this is the basic architecture of your 8255. Now your 8255 can work in three modes. Okay, so let's discuss which are the three modes. So it can work in mode 0, mode 1, or mode 2. Mode 0 is a simple mode where no handshaking occurs. Mode 1 is handshaking mode, and mode 2 is bi-directional handshaking, right? We'll not go into detail of this currently, right? And there are three ports, as we know. Devices can attach with port A, port B, or port C. So in mode 0 all port can work fine, no issue. Port C can take data, put data, port A can take data, put data, and same with B. In mode 1 port A can do handshaking, port B can do handshaking. Now C can't do that. Why? Because we have already seen in our previous stuff that C the upper part of C lines are used for handshaking purpose for A port, and below lines of port C will be used for handshaking with B. So C will not be used. Same way in bidirectional mode only port A will be used. B can't be in mode 2, it can be in mode 1 or mode 0 only, and C as usual can be utilized for handshaking purpose, right? So this is the table. Fine. Now based on this table, as we have already seen, there are two registers that you can control, right? So there are two commands, IO command and BSR command. Both are address 86H in our case. We have taken the example. Now both are 8-bit registers, as you can see. The MSB bit in both the case represent, it will tell the 8255 that the command is for BSR or it is IO. So if bit is 1, it is IO command. If it is 0, it is BSR command. Fine. Now let's first discuss IO command. In IO command, it is divided into two parts. As you can clearly see, I have used the different colors. So this part is for port A, this part is for port B. Now in port A, it can be in any of the mode, right? it can be in 0 mode, it can be in 1 mode, it can be in 2 mode. So first thing that we need to decide is your port A is in which mode. So for deciding these three things, you can have 0 0 0 1 1 0 and 1 1. Now this means 0 mode, this means 1 mode, anything from this means 2 mode. So we require 2 bits which decide the mode. Fine. Next is it will work as input or output. So if here it will be 1, so it is based on the device that you have attached with port A. If it is input device, it will be 1. If it is output device, it will be 0. Right? Now C. Okay. Now we'll come later on for C. Let's discuss about B. Now for B you are having only 1 bit. Why? B can be in mode 1 or mode 0. Right? So 0 means mode 0, 1 means mode 1. So we don't require 2 bit, we only require 1 bit for port B. Right? Now port B can be of input or can be of output. Again only 1 bit is needed. So here it is. Right? Now if my port A is 0 0, mode of port A is 0 0, mode of port B will be 0. We know that port C is by default in mode 0. So we don't need to define the mode of port C. That's why there is nothing called mode C. Right? Mode of port C is not needed. Why it is not needed? Because based on the A and B, you can easily say that your C will be in which mode. If my port A will be in 0 mode by default, and if my port B is also in 0 mode, my port C will be in 0 mode only. Right? If my port A is in mode 1, I need to use C as a handshaking. If my port B will be in mode 1, I need to use C as a handshaking. So by seeing port A and port B in which mode they are working, we can easily identify in which mode our port C will work. Right? So for that we are not defining mode. Now we need to define port C as working as input or output. Right? So upper and bottom part, because both will work differently. So for both we need to decide it will be working as input or output. So suppose I have decided that currently it is my IO word. Fine. A will work in 0 0 mode, B will work in 0 mode. It means my C will be default in 0 mode. Right? The A will work as input device, B will work as input device. Now normally PC upper and PC lower will be together decide same bit, because it is not normally used as separate part. So both will be 0, or in case both will be 1. There are very rare chances that one can be 1 and other will be 0. Most of the times both will be 0 or both will be 1. So what that mean? This is the scenario where I can say that my port A, port B, port C. My port A will work in mode 0, port B will work in mode 0, port C will work in mode 0. My port A is having input device, my port B is having input device, and my port C is both are having 0, so it will work as output device. So for this is the configuration. And if you converted this number into binary, right, so 1110 is 9, 0010 is 2, so 92H. So if you want to do is in a program, how it will be written: move AL, 92H in 8086 and out command 86H, AL. So it will paste 86H is the address of my 8255. So on 8255 we are writing this IO command. This is how you can write down programmatically. I hope this is clear. Same way we are having one more command, BESR, beat set reset. Now port C is having 8 lines. We know that, right? Now we know that when you are using handshaking, these 8 lines will be used by port A and port B. Upper will be by port A, below will be by port B. It is possible that sometimes port A is only going to use only first 3 lines and port B is only going to use below 3 lines. So in that case we are having these 2 lines which is available to us and we can utilize it. Though it is handshaking, still we can utilize it. That kind of scenario is possible. So what 8255 has done is it is giving us the facility that we can individually handle the bit. Now as you can individually handle the bit, as you can see all upper discussion, we are normally handling full register. We are never handling particular bit of a register. We are handling full register every time. But 8255 will give us the facility that we can individually handle the each line or each bit of our port C. That facility is given by 8255. There are lots of practical applications of this particular stuff, right? We are not going to discuss it, but this facility is given. And how you can do that? Here if it is 0, we know that it is BSR command. These 3 bits are don't care because we are not going to use it. And PC. So here if you pass 000, that means you want to do something with first bit. If it is 111, you know that you want to do something with 7 number pin. If it is 010, we know that you need to do something with 2 number pin. So likewise, and here last is set reset pin. So if I pass 0 x, here it is 110 and 1. What that means? I want to do 6 bit set, so I can do something with bit number 6. If I make 1110, what that mean? I want to make 7 number pin reset. So that kind of work you can do with port C specifically, and for that BSR command is available. I hope this much thing is clear, right? Thank you for watching.